To our video. I think we're on part 3 of the trig identity series that I'm making. So we have a trig identity series, and we're going to look in this video specifically at negative angle measures. And this, I mean, as soon as you have a negative angle measure, you should think, what does that even mean? Well, this is another good example of when we need to go beyond just using a triangle, because with a right triangle, if you're looking at trigonometry and the relationship of a triangle and looking to see what's going on with sine and cosine and maybe of this angle over here, right? We can't even use this model to think about, well, what is the sine of negative 30 equal? And what is the cosine or tangent of negative angles? To deal with negative angles, we need a unit circle. And that's just a classic example of why the unit circle doesn't replace the idea of the triangle. It just extends how we use the triangle to deal with negative angles. And let me show you what I mean. So the unit circle, right? We set up our axes here. Let me change colors so we have our y and our x axes. And then we put our unit circle in. Okay, there's some interesting results with negative angles, and I think they make a lot of sense if we look at them in terms of the unit circle. The identities we're going to look at are the sine of a negative angle equals the negative sine of the positive version of that angle. And then we're going to look at the cosine, which I think really fascinates me. The cosine of a negative angle is in fact equal to the cosine of the positive version of that angle. And so related to these and built off these, the secant, right, of a negative angle will equal the secant of that positive angle. I'm using x here. And the building off of sine, right, the inverse of sine is the cosecant. So the cosecant, just like it'll behave like the sine will behave, so the cosecant of a negative angle will equal the negative cosecant of the positive version of that angle. So just notice here, well, if the cosine behaves in a certain way, what's its inverse? Well, its inverse is the secant. So the secant is going to behave in the same way. And same thing with the sine. If we have the sine behaving a certain way, the cosecant will also do the same thing. And we have to look at tangent, of course. The tangent of a negative angle, negative theta or negative x or whatever. I've been changing symbols here, though I definitely should use the same one. Let me just put thetas in here as well. So the tangent of a negative theta is going to equal the negative tangent of positive theta, and then cotangent will behave the same way, because that's the inverse of the tangent. So the tangent, if we take the tangent of a negative angle, that'll equal the negative tangent of the positive version of that angle. Well, the same thing's going to happen with cotangent. So that just the cotangent of negative theta equals the negative cotangent of positive theta. Okay, so what does all this mean, and what's going on here? Let's look at the cosine first, because that's the one that really strikes me. Now, the cosine is an even function, and we're not going to go into what that means here, but we can still understand why the cosine, regardless if the angle is positive or negative, will give us the same result. Let's look at the cosine of 30 degrees and compare that to the cosine of negative 30 degrees. So, well, what does that look like? Well, the cosine of 30 degrees, we're going to draw a radius in the circle, about 30 degrees, up from the x-axis, drop the triangle down, and now I got this right triangle and my theta right here. This is my cosine of 30 degrees right there. So the cosine of 30 degrees, if you remember from our discussions in the other videos about the unit circle, what's going to happen here is that the height of this triangle, right, the cosine equals the adjacent side over the hypotenuse, so only these sides are really going to matter. And in fact, what we're going to get for the cosine of 30 degrees, if we map this out, it's going to be the square root of 3 over 2. So let me just put that up here. That's this length, the square root of 3. Actually, that's a little bit too thick. So square root of 3 over 2. Okay? and then the height is 1/2, and that's relates to sine. But what does it mean for, so anyways, I'm sorry. So the cosine is equal to the x value. We talked about that in other videos, right? The cosine is the adjacent side over the hypotenuse, and the hypotenuse is just 1 here. So adjacent side over hypotenuse, if the adjacent side is the radical 3/2 long, then that's what the cosine equals, because the hypotenuse is just 1. What about the cosine of negative 30? Well, what does that mean? And this is where the unit circle is powerful, because instead of trying to figure out how a negative angle fits into a triangle, we can think of positive and negative as direction. So if positive is opening up counterclockwise, then negative will open up the other way clockwise. So we can just draw a 30-degree angle this way, and then do the same thing with a triangle. It's almost like a reflection here. It should be actually a perfect reflection. It's just the way I drew the circles a little bit off. And notice all we did to create a negative angle is go in the other direction. So we might, at this point, even see what's going to happen. This is now our cosine of negative 30, and the cosine is just going to equal the x value. So it doesn't matter that the triangle is now upside down. The x value, this distance, is still positive, and it's still the same length. And if we figure out the point right here, we could do the same thing. It's the y value that changes, and that's the sine value. So we have the radical 3/2 is still positive, and that's our x value. So it still equals radical 3/2. But the sine value is negative, right? So actually what's going on here is that the sine value, right, we have, so first of all, the cosine of a negative angle is going to equal the cosine of the positive angle. So cosine of negative 40 is going to equal the cosine of positive 40, and so forth. We showed it for cosine of 30 and negative 30. And I mean, we're not going to go through the secant here, but if the secant is just the inverse of the cosine, right? So the inverse of radical 3/2, we can show real quick. The secant of 30 degrees is going to be 1 divided by, or 1 over, the square root of 3/2, and that just, this is pretty sloppy, is going to equal 2 over radical 3. You want to multiply the numerator and denominator by radical 3, and you get radical 3 over 3, so 2 radical 3/3. And the same thing is going to happen here. The secant of negative 30 is just going to be, right, 1 divided by radical 3/2, and that's going to end up being the same thing. So secant and cosine don't change for negative or positive values of angles. However, sine, cosecant, tangent, and cotangent all do. And we can look at this diagram to understand sine. The sine values are the y values. So in the first case, the y value is going up, and the sine of 30 degrees is going to equal 1/2. But in the second case, we have this negative angle, and the y value is pointing down, and so sine equals this value right here, and that's, I cut it off there, but the sine of, oops, can't see that. The sine of negative 30 is going to equal negative 1/2, and that's the same thing as we say up here, that if you were to find the sine of 30 and then multiply it by a negative 1, which is what this means, you'll get the same thing as if you find the sine of negative 30. So that's a good hint too, because that means when you're finding the sine of a negative value, you can still use your right triangle model, find the sine of a positive angle, and just multiply it by a negative number. So that, here we could have, instead of using the unit circle and drawing the triangle down, I could have said, well, what is the sine of 30 degrees? Oh, it's 1/2. Well, if I'm trying to find the sine of negative 30, it's negative sine of 30, or negative half. And the cosecant, for the same reasons as the secant did behave the same way as the cosine, it'll behave the same way as sine. So it's just going to be the inverse of the sine function, and I'll leave it to you to explore that. Now the tangent we should just go over really quickly. The tangent, again, is a ratio of sine to cosine. So the tangent of an angle equals the sine of that angle over the cosine of that angle. So what does the tangent of a negative angle have to equal? Well, that means it's going to equal the sine of negative theta over the cosine of negative theta. Well, we just kind of went through this. The cosine of negative theta, what's that? Well, that's just equal to the cosine of positive theta. And what's the sine of negative theta? Well, that's negative sine of theta. And what does that equal? Well, that's like saying the negative sine divided by positive cosine. That's what's a negative tangent, right? We can think of it as, what if we had negative 1 over 2? That's like negative 1/2, right? Because there's one negative sign with one of these parts of the fraction, so the whole fraction is negative. So same thing here. We have one negative sign for this part of the fraction, so the whole fraction is negative. So you can think of this as negative sine of theta over the cosine of theta, and that's just negative tangent of theta. And so tangent of negative theta equals the negative tangent of positive theta. So if you wanted to find out, well, what's the tangent of negative 30 degrees? Well, you could first just solve the tangent of 30 degrees, and if you want to find that, you could just plug it in your calculator or build the unit circle, and it's going to be the ratio of y over x in that circle, so it's going to be the ratio of 1/2 to radical 3 over 2, and you get something up close to 0.577. Let's round here to so that's 0.5774. So if I want to know the tangent of negative 30, I would just take the negative of that value, so it would be negative 0.5774. And those are some pretty basic trig identities for negative angle values.